This problem again takes a look at the procedures of CPR. For many years, chest compressions were combined with mouth-to-mouth resuscitation in the standard CPR procedures to resuscitate someone. However, some people believe that not using mouth-to-mouth and just doing the chest compression would be a better way to do it. So they wanted to set up a test that would show that this was the case. So jumping down to the bottom here, we have our null hypothesis and our alternative. Our null says that the survival rates for the two treatments are equal. That's always the null, that the proportion that survived one is the same as the proportion that survived the other, or if it was a test of the mean, that the two means were equal. The alternative is that the treatment for using just chest compressions has a higher survival rate, so that that proportion can be higher than the one of the mix. So if I had to rewrite that using symbols, I would say proportion for just CC is equal to proportion for the mix, and then the proportion for the chest compressions is greater than the proportion for the mix. So either way, we don't do any calculating, and we're given a p-value right here, 0.0761. Interpret what this means in the context of this study. Well, in the context of this study, we're going to try to understand what exactly a p-value tells us. It's how likely we are to see the results as extreme as the results that we saw, assuming that the null hypothesis would be true. So that means that there's a 7.6% chance in this case of seeing results such as the ones above. We had 278 out of, excuse me, if you read this a little more in depth here, you'll see that it is 29 out of 278 for the chest compression plus the mouth-to-mouth group. So 29 survived out of the 278. And then in the only chest compressions, 35 survived out of a sample of 240. So that's the two proportions that you have. And what we're talking about here is not putting these in our calculator, but just trying to say that the likelihood of seeing results as extreme as the ones that we actually got is only 7.6%, which is not particularly high, but also, again, not super low. So that's what the p-value is telling us. Part B is based on this p-value and study design, what conclusion can be drawn in the context of the study with an alpha of 0.05. Well, if alpha is 0.05 and our p-value is 0.07 something, then we fail to reject. We do not reject the null hypothesis. And so, in the case of the study, we would say that there is no statistically significant difference between the two treatments, that we'll side with the null that the two treatments are essentially equal. We don't have evidence to prove that that's not the case. Part C is based on the conclusion above, what type of error could have been made. Well, if we fail to reject, then a type 1 error is out, so we're left with only a type 2 error that could be made. What is one potential consequence? Well, one consequence could be that you're taking a good treatment, which is that the chest compressions alone might be a better way to treat people than the existing treatment of using the mouth-to-mouth and the chest compressions. And you might not be able to use chest compressions because you haven't proved that it's going to work. At a p-value of 0.07, you suspect that the chest compressions alone are actually the better solution, but because you don't have a value below 0.05, that type 2 error might mean that people are not going to receive the best treatment available. So my recommendation in this situation would, again, be to get a larger study, and this is already a fairly large study, but expand it and see if you can replicate that get that p-value down to a point where you can truly conclude that chest compressions alone are the better treatment, and then recommend that medically.